Hit it. Where's Wally? Where's Wally? Did you say him? Where's Wally?
Where's Wally? Where's Wally?
Where's Wally? Where's Wally?
I remember when I was a kid, I really enjoyed reading these Where's Waldo books, or where I grew up, we called them Où est Charlie in French. Or you also could call them Where's Wally, which is really weird to me, but apparently in England that's what they're called. Basically, if you guys never read these books, it's just 2-page illustrations, and the goal is just to find this character called Waldo, or Wally, or Charlie, who has these really creepy glasses inside of huge crowds. And the goal was to find him as fast as possible. So today I had the brilliant idea of making a machine do that for you, because we're moving into a day and age where AI is everywhere around us. So I thought it may be a cool challenge for me to try and build an AI that could find Waldo for me. We're gonna see how the AI I built performs, if it can even find Waldo, and we're gonna see if it does find Waldo, how much time it will take. And basically I'm gonna compete against my own AI, and let's see what happens. Alright, so the first thing I tried was using OpenTV, which is an extremely popular library for computer vision in Python. The specific method I used was something called FLAN, which stands for Fast Library for Approximate Nearest Neighbor. It sounds complicated because it is, but basically what I did is feed it an image of Waldo, and then I tried giving it other images where there's not only Waldo but like a bunch of other faces, and it tries to fit the original Waldo face inside of the much larger picture and find if they could fit. And if there is a match, then it could outline that face. Now this sounds great in theory, but in practice when I tried this, it went horribly, and it couldn't find Waldo at all because the face was too small. I'll show you guys the results. I tried everything, but I couldn't get very far.
Nope.
So the second thing I tried was using Google Cloud Services, and the specific service I used was called AutoML Vision. Now AutoML stands for Automated Machine Learning, and what's great about AutoML is that some of the services, such as the one offered by Google, can let you do some machine learning without any lines of code at all. So all you had to do was upload your images and hand label your data. And with that data, Google will train it and they'll find the best parameters to learn from it. So it's really simple, and I tried it out for our Waldo dataset, and all I had to do was upload the images and select where Waldo was in each picture, and Google's AutoML Vision will use their object detection algorithm and train it on the images that I've labeled, and it will be able to find objects on the new image. So the first time I tried running the Google model, it actually didn't run for some reason. Google requires at least 8 training images, 1 test image, and 1 validation image, so a minimum of 10 total images that are labeled with the Waldo. I gave it like 25 images and it just didn't want to work. And what I realized was, for some reason, the box which I labeled Waldo's face in was too small for some pictures, so it didn't recognize it. So I could assign it to test and train, but it didn't want to go into validation. So anyways, I made it work in the end, and I think I've tried 3 different models. So now let's actually go ahead and do the exciting part, which is upload an image on which the model hasn't been trained on before, and let's see if the computer can actually find the face without me telling it where Waldo is. Alright, so clearly our model doesn't work as well as we would have wanted it to. But to show you guys that it still technically works, if we feed it images that it has already seen before, we can see that it can accurately predict where Waldo is. But that's kind of cheating, right? Because the AI already knows where Waldo is. So why can't our model perform well on new images that it hasn't seen before? Well, I think there's really 3 main reasons in this project that has led to a very poor performance from our model. Firstly, I think we need way more training data. So in this project, we only gave it 40 images, but we can go in the thousands of samples. The second reason, I mentioned this before with the OpenTV project, is that our Waldo face is way too small compared to the rest of the picture. And you can see that in some of the pictures, it's getting really pixelated when you zoom into Waldo's face. So the AI itself is getting a hard time trying to recognize what Waldo's face might actually look like. And finally, I think the biggest reason is the fact that, man, Waldo looks so different in all these pictures. I mean, look at him. There's one with round glasses, one with these half-rounded glasses, and then one has so much space in between the glasses, and the other one has 2 like circles like right next to each other. It's just not consistent from face to face. How do you expect an AI to recognize who Waldo is if his face keeps changing? So to conclude, I tried to make a computer vision model to find where Waldo is, but in the end, I didn't succeed. I tried my best. So sorry mom, sorry dad, I'm a failure. I'm a failure. But if you guys want to see a part 2 of me trying this again, please make sure to subscribe, leave a comment, leave a like, let me know what you think, and I'll see you guys in the next video.